Here's another helper function rule. It says that when we shift knowledge domain, we should use a helper function. That sounds kind of weird, but really all it's saying is that if we're in the middle of designing a function about one thing, maybe this function is about apples, and then we need to do a very different kind of thing, maybe oranges, then right there is where we should put a helper function call. Maybe the apples and oranges doesn't explain it, but I think if you look at the example in this video, you'll be able to understand when to use this rule. Now I'm working on finishing the insert function. We've already got the wish list entry, so the next thing to do is to work on the examples. And at this point in this program, what I'm going to realize is, gee, I've got a lot of examples involving images of different sizes, and they get kind of cumbersome to write. So I'm going to do something that I might have done earlier. It's fine that I didn't do it earlier, and I don't absolutely have to do it now. I'm just doing it so that you can see it happen. What I'm going to do is I'm going to take these examples that I've been using, and I'm going to take the images that I've been using, and I'm going to turn them into named constants. So for example, this shows up in a lot of my examples. I'll just go up here to constants, and I'll make a special section of them called for testing. And I'll say define I1 is this thing. And then what I'll do is I'll say let's find every occurrence of this thing, and we'll replace it with I1. Well, we're not going to replace that one because that would be circular, but we will replace this one and 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 this one. There were a lot of them. Not that one. And then we'll do it again for the other ones. 20, 30 solid red. And 30, 40 solid green. And one important thing here is I ran it. And unfortunately, the program wasn't working when I ran it because we knew that. We were in the middle of working. And so I'm not certain that I didn't make any mistakes, but I did it so systematically using find replace that I probably didn't make any mistakes. Whenever you do something like this, you want to at very least rerun it to make sure your program is still well formed. And what I probably would also do is take the trouble to redo the line breaking. And in some programming environments, you would get some more automatic support for this kind of thing. Basically, you're taking a recurring constant expression and replacing it by a named constant. That's a refactoring that some tools will give you automatic support for. And that kind of support has been in programming environments for years and years and years. Larry Macinter put that in the interlisp deprogramming environment in the 80s, at least that long ago. All right, now we're back to insert. So let's do some examples. So we're going to insert some image. Well, now we've got names for images. So we'll insert I1 into, we need the base case example first. So if you insert an image into an empty list, there's only one place for it to go, which is at the beginning of the list. So that's the result there. Now let's see. Another example is to insert I1 into a list that already has I2 and I3 in it. And in that case, it goes right at the beginning. And now that I've got these nice named constants, I can really do all three cases. Let's also insert I2, which goes in the middle. And we'll produce that result. And let's also insert I3 which produces that result. So now we've kind of got the full space. It either goes at the beginning of an empty list, or it goes at the beginning of a non-empty list, or it's somewhere in the middle of a non-empty list, or at the end of a non-empty list. That looks pretty good. Now we got some examples. Let's run them to make sure they're well formed. Oop, one of my examples isn't well formed. And since I copied and pasted, it's going to happen a bunch of times. There, that empty. That's okay, we'll fix it quickly. Let's try it again. Okay, now they're well formed, but of course they're failing because of the stub. Let's see, let's go get the template. And we'll copy the template down here. We'll comment out the stub. Oh dear. When we were designing this, we named the parameter LST, and we tend to name them LOI. There's two ways to fix this. One is to go ahead and name it LST throughout this function. The other way is to be more consistent with what we were doing in other functions. Both work, but I think what I'll do here is just I'll take the approach of being more consistent. I'll change that to LOI and that to LOI, and I'll do it too in the stub, even though the stub has been commented out now. I just like being consistent. So now LOI has the right name, but I do need to rename the function itself and rename the natural recursion. And this is a function that takes 2 arguments, whereas the template, of course, only takes 1. So we have to add the second argument, image. And remember, if you go to the design recipes page and you go to the data-driven templates page, there's a rule that when designing functions that consume additional atomic parameters, the name of that parameter gets added after every ... in the template. So we got to do that here. So let's see, IMG is going to go there, and it's going to go there. And something has to happen here because insert wants 2 arguments. So I'll just put ... IMG. You could put that. Sometimes I would just put that. But I'll put ... IMG in this case. Okay, they're both equivalent. Both are a note to myself saying, hey, remember, insert needs 2 arguments. So now let's get going. In the base case, we're inserting image into an empty list. And that corresponds to this first example. And so we just put this image on the front of an empty list, like that. The next 3 examples are telling me that sometimes the inserted image goes right at the front of the list, and sometimes it doesn't. In this first case, I1, the image that we're trying to insert, is not larger than I2. And so that means I1 has to go before I2. That's what it means for the items to be in increasing order of size. Because I2 is bigger than I1, I2 has to be after I1. But in this blue case, we're trying to insert I2, and the first item in the list is I1. And I2 is bigger than I1. So that means I2 has to go after I1 somewhere. Again, that's what it means for them to be sorted in increasing order of size. And the same is true for this blue case. I3 is larger than I2, so I3's got to go somewhere after I2 in the list. So what these examples are telling me is that at the very least there's got to be an if here, because there's a case where I1, the inserted item, goes at the beginning of the list, and there's cases, the I2 and I3 cases, where the inserted item doesn't go at the beginning of the list. So there's got to be an if. And if there's an if, there has to be a question. So what's the question? Well, the question has to do with comparing the sizes of the image to be inserted with the first item of the list. So we need to do something here with these two things to know, is image bigger than the first thing in the list? And you might put a note to yourself here, is bigger. Now the question is, how are we going to do that? Well, we need to determine if the area is different. So we're going to have to get the width and height of the image and the width and height of the first thing in the list, and we kind of have to determine their relative sizes. But that's kind of complicated. And not only is it kind of complicated, but it's about a different kind of issue. This function is really about inserting into a sorted list. Whereas this little piece of code here is about comparing sizes. And sorting a list is one kind of knowledge, and comparing sizes of images is a different kind of knowledge. So what we've got here is a knowledge domain shift. We're shifting from knowledge about sorting lists to knowledge about comparing the size of images. And there's a helper rule that says when the knowledge domain shifts, you use a new helper. So I'm going to wish that there was some other function called larger that compares the size of these two images and produces true if the first image is larger than the remaining images. And if image is larger than the first thing in the list, then what happens? Well, that means image is going to go somewhere after the first thing in the list. So what we're going to want to do is say something like cons, the first thing in the list, I2 is bigger than I1. So I1, the first thing in the list, is going to come first, and then we'll have the natural recursion. And the natural recursion will just take image as its first argument. And what this says is it says put image somewhere in the rest of the list and put the current first of the list in front of that. Otherwise, if image isn't larger than the first thing in the list, then this is where it goes. So we're just going to put image right here at the front of the list. There it is. Now we've wished for this function larger, so let's make the wish list entry. It consumes an image and another image, and it produces a Boolean. Produce true if image 1 is larger than image 2 by area. It's a wish list entry. There's the stub. Let's get rid of hide replace now and run and see if we're well formed. We are well formed, but a bunch of tests are failing. So what's happened here in this function is we made some name constants in order to make our tests look better. We just methodically generated all possible variants for the tests, copied the template as usual, added a parameter, and then it was all pretty clear what we were going to do. We needed to know the relationship in size between image and the first thing in the list. But that involved a knowledge domain shift. We were switching from the domain of sorting lists to the domain of comparing the size of images. Those are two different kinds of knowledge, and so there's a rule that says that's a good place to put a helper function. So we wished for larger, and that's where we are right now. Turning again to this overview diagram, where we're at is that arrange images is done, but it's waiting for sort images to be done. But sort images is done, except it's waiting for insert to be done, and insert is waiting for larger to be done. So arrange images, sort images, and insert are fully coded. But until larger is done, we can't really be sure that those other functions are done. And larger is what we're going to do in the next video.